Hey everyone, it's James, and in this video, I'll be talking a little bit about debugging. In a bit more detail, I'll be talking about strategies for debugging asynchronous code, specifically promise-based code. If you haven't watched Braxton's video on promises, you should go watch them now. I'll also be showing you how to use a really cool tool called the evaluator. This lets you execute expressions during a debugging session. Okay, so the project we're going to be working with for this tutorial is Promise Math. So Promise Math is just an API for accessing, the solutions to mathematical expressions, and it's promise-based, as you can tell from the name. So there are four methods that we're interested in. The first one is do normal math, and this one just takes an expression as a string and returns a promise with its solution as a number. Batch process math takes a list of expressions as strings and returns the result of solving those expressions as an array of numbers. Doer math is kind of weird, as the name might suggest, because it evaluates the initial expression evaluated by the string, then it multiplies the result by 2 using a call to the API, and then it raises the result to the power of 2, and it also returns a number. The last thing we want to look at is do math with callback. This one implements the same functionality as do normal math, but without using any other libraries other than the request. You'll need to convert the callback-based code to a promise, but the implementation of all these methods is already done for you. So if you want to go about doing this yourself, stop the video at this point and give it a shot. All right, so now we're in promisemath.spec.ts, which is the test file we're going to be working with to kind of learn about debugging. So let's take a look at the first unit test. It says do normal math should compute a simple addition expression. So the expression whose value we want to compute is right here, 5 plus 9, and we have a call to math.doNormalMath. And then we expect the result we get back from the promise to equal 5 plus 9. In the event of an error, we catch the error and say we failed to compute expression with error, and we print out the given error. So again, if you haven't watched the promise tutorial by Braxton, it's a pretty good idea to go about it now. So let's run this test by clicking this little play button right next to the unit test. And I'm going to click run. And we see here in the results window that, okay, test results, math promise.doNormalMath should compute a simple addition expression. It successfully passed. So that's really good, but let's kind of take a step back and look under the hood to see what's exactly happening. So with promise-based code and promise-based tests, there are three areas that you really want to pay attention to. The first is the actual call to the asynchronous function. So I'm going to put a breakpoint right here. The second is the then block, which contains logic that we're going to execute if the promise successfully resolves. So I'm going to put another breakpoint that corresponds to it. And the last thing we want to pay attention to is the catch block, which contains our error handling logic. So I'm going to put another breakpoint right here. Okay, so setting these three breakpoints kind of tells the debugger, hey, I want you to stop whenever I hit any of these three breakpoints. So I'm going to run, or rather debug this test by going to the play button, clicking it, and selecting debug. And we see that the debugger stops at our first breakpoint, where it's the line return math.doNormalMath expression. So if you look at the variable window here, we see that expression is 5 plus 9, and that's kind of what we want. You can also see the value of the expression inline right next to the breakpoint here as 5 plus 9. So we're going to step into this function call, and okay, so we're here right now at doNormalMath, and hey, here's another example of where we want to set another breakpoint. Remember, I told you that the then block is an interesting place to set a breakpoint, so let's put one right here. Okay, so let's run the file or resume our program until it hits that breakpoint. So resume. Okay. So here we see that the results string, which is the result we got back from calling our API with our expression, is 14. Remember, the expression we had was 5 plus 9, and we know that 5 plus 9 is 14, so that worked out pretty well. And since doNormalMath returns a promise that contains a number, we're going to have to convert our string 14 to a number, and that's what we're doing here. Okay, so everything so far looks so good. So I'm going to click resume, and hitting this will basically take us to our next breakpoint in our program, which is going to be the then block inside our test. Okay, so we're now inside our then block, and we say that, okay, we have our expectation, and we have our result that's returned from our asynchronous function call, 14, and we're gonna return our expectation that the result is going to equal the value of the number 5 plus 9, which is 14. So let's resume our program, and here we shouldn't get to the breakpoint on line 18 because we're not going to throw an error. So let's test our hypothesis. So let's resume our program, and it looks like the debugger quit. So if we look at the console, our test passed and we didn't hit the breakpoint on line 18, which is the inside of the catch block, as we expected. All right, so good work on debugging your first asynchronous program. So let's move on to the next one. So this unit test is batch process math should be able to compute an array of expressions. So what this means is we take an array of expressions as strings. So we have 2 plus 4, square root of 9 times 11, 5 minus 10, and the result should be 6, 33, and negative 5. So let's just run this test to see if our logic is correct. So I'm going to click run. Okay, not great. So we get an assertion error where we failed our expectation. So this is a case where things are going to get a little bit more interesting. So let's get started. You can probably see where this is going. I'm going to do the same thing we did before. So I'll set a breakpoint at the asynchronous function call. I'll set a breakpoint within the then block, and then I'll also set a breakpoint within the catch block. Okay, since we have all our breakpoints, we're now going to click debug on our unit test. Okay, so we've hit the first breakpoint, which is prior to the initial function call. So let's check out our expressions to see if they're well formed. And yeah, it looks like they're fine. We have the string 2 plus 4, square root of 9 times 11, and 5 minus 10, which is what we wrote down on line 23. So let's step into the async function call. Okay, so we're in batch process math. And here we kind of want to set 2 breakpoints, which is one at the very end of the function to see what value we return. So I'm going to set a breakpoint on line 20. And I'm also going to set a breakpoint inside the loop body, which is on line 18, because that's kind of the place where a lot of the state update is going to happen in our function. So let's run our program to see what happens. Okay, so let's take a look at our expressions or our variables in the variable window. We see that the expression is 0. Okay, well that doesn't really make sense because we have a for loop over our expressions, and we know that our expressions contains the values 2 plus 4, square root of 9 times 11, and 5 minus 10. So let's take a look and see what's really happening here. Okay, so here's where we get to use something called the evaluator. So I'm going to click this button that looks kind of like a calculator, and a window pops up. So this basically lets you compute the value of expressions that you might have in your code. So if I do future expressions and hit evaluate, or you can either click this button or hit return or enter, I get a result back and it's an empty array. So let's check the value of expressions, which is the mathematical expressions that we pass into the array. So expressions. And okay, we get back the result, and it's a list of mathematical expressions: 2 plus 4, square root of 9 times 11, 5 minus 10. That's great. So cool. So this kind of tells me that I'm not iterating over the array properly. So I'm going to take a look for const expressions in. Okay, so it looks like I wasn't paying attention to my own TypeScript tutorial, because we know that using in makes us iterate over the indices of the array. So just to be sure, I'm going to close the evaluator, and let's hit a few more iterations of the loop. So I'm going to hit resume. So expressions is now 1. Resume again. Expressions is now 2. And just to be sure, resume. Expressions, okay, is now 0, 1, and 2. Those were the indices of the array. So it looks like what we're doing is we're passing the numbers 1, 2, 3 to the function doNormalMath. And we're not actually passing in the expressions in the expression array. So let's fix this by stopping the debugger and changing in to of. And let's see what happens one more time after we run our code. So I'm going to go back to our promisemath.spec.ts. I'm going to hit debug. Cool, so we're right before the function call. Let's step into our function call. Cool, so future expressions empty array like always. So let's go right into the loop. Okay, so it looks like our expression is 2 plus 4. That's great. Let's go one more time. Our expression is square root of 9 times 11. Great. And just to be sure, okay, so our final expression is 5 minus 10, which is the last expression in our array. So I'm going to remove our breakpoints on line 18 and on line 20, and I'm going to hit resume. And okay, so we're in our then block, which means our promise resolved successfully. And we see that the result array is an array of numbers containing 6, 33, and -5. So let's try to use our evaluator to kind of get the result. So let's type in result or results, because it's what's passed into our callback function to .then. And if we hit evaluate, we get a result array back containing 6, 33, and 5. So let's close our evaluator. And if we hit resume, we shouldn't hit the catch block. Okay, so it looks like the debugger quit, and we've basically fixed our bug. So that's great. All right, now that you have some strategies to debug asynchronous code, and you're equipped to use the evaluator, you should try debugging this last test. So I'm going to run, should be able to correctly execute weird math. And you'll see that it fails. So like I did before, you should start by setting a breakpoint at the asynchronous function call, set a breakpoint within the then block, and set a breakpoint within the catch block, and hitting debug. Good luck.